This is a fantastic question on magic squares, looking at some properties of a particular one, a 3 by 3 magic square where we're using the digits from 1 to 9. So we're asked to show that the magic number n, that is the sum of every row, column, and diagonal, is 15. Let's have a go. Well, we must have that a plus b plus c is equal to n, and d plus e plus f is also equal to n, as is the bottom row. So if we add all of these together, then we're going to get 3n. But here's the thing, we don't know which is which, but we do know that we're going to be using all the numbers from 1 to 9. So it must be that 1 plus 2 plus 3 up to 9 is equal to 3n. You can add them up by hand, or you can use the triangle number formula, a half times 9 times 10. So 1 plus 2, this is 1 to definitely learn, plus n is a half n plus 1, which is going to be 45. 9 times 10, 90. Divide by 2, 45. Divide by 3 to get n. N must equal 15. So if a magic square is possible, then the magic number has to be 15. Now I have to show that the middle number must be 5. And what we're going to do is very similar sort of thing, but this time, instead of adding all of the rows, I'm going to add the diagonals. A plus E plus K, that must equal 15. And so must C plus E plus G. And then if I take the middle ones, because I'm trying to use E as much as I can, because that's the one I'm trying to work out. I've got D plus E plus F is 15, and B plus E plus H is 15. Note, I've got every single letter once except E, which I have 4 times. So therefore, we're going to have A, if I add them all together, A plus B plus C plus D plus E plus F plus G plus H plus K plus this extra 3E, that's going to equal 60. And we've already said that this here is 45, so therefore 3E is going to be 15 and E is going to equal 5. Brilliant. On to part 3, we're asked to show that 1 of B, D, H, or F must be 9, i.e., well, we know that E is not equal to 9 from part 2. So we just need to show that the corner ones are not equal to 9. So suppose A equals 9. Let's see what happens if that is true. Then it would follow that K has to equal 1. So we'd have 9, B, C, D, 5, F, G, H, 1. So B plus C would have to equal 6, and D plus G would have to equal 6 to get our magic number of 15 overall. But we've only got, we can't use 1 and 5, so we've only got 2 and 4 to make this out of. Okay, you can't use 3 and 3 either. So not possible to satisfy these equations. Therefore, A not equal to 9. And we can make the same argument for the other corner ones because there's nothing special about A. Same arguments can be made. C, G, and then K. Sometimes we say without loss of generality, so we could say WLOG, suppose without loss of generality, A equals 9, then it follows that it's going to be true for C, G, and K as well, because they're also on the corner. We can imagine rotating the grids, then G would be up here, for example, so you can see the same argument applies. And therefore, I could say the result follows, or let me just write it down. 1 of B, D, H, or F equals 9. Good. So we're into the later stages now, part 4. Find all 3 by 3 magic squares where B is equal to 9. So I've got A, 9, C, D, 5, F, G, 1, and then K. So B equals 9, E equals 5, must have H equaling 1. Now let's look along this row. So A plus C must equal 6, and therefore A is going to equal 2 or 4, because it can't equal, we can't use 1 and 5, it can't equal 3, because we can't use 3 twice. So let's look at those two situations. A equaling 2 means we'd have 2, 9, 5, 1. Then C would equal 4. And then it would have to be, just follows that G, get 9 here, G would have to equal 6. We have 8, so D would have to equal 7. Here I've got 12, so F would have to equal 3. And finally, K would have to equal 8. So this is a possible solution. Let's now look at if A is equal to 4. We're going to get a second solution. So 4, 9, this time C is going to equal 2. And then, well, we could look at a few different places. This one could be 6, so K is 6. And then G would equal 8. D would equal 3. And finally, F would equal 7. Okay, brilliant. So find all 3 by 3 magic squares of B equals 9. There are two solutions. Finally, how many different 3 by 3 magic squares are there and why? They're different if they have different entries in any place of the array. Well, we found that there were two solutions for B equals 9, and there's going to be 2 for each of the others, for each of D, F, H equaling 9, and therefore 8 solutions in total. There's nothing special about B equaling 9, we just get a very similar grid for the others, just a rotation essentially. So we could can also obtain by rotating the two grids from part 4 by 0 degrees to get the ones that are actually shown, 90 degrees to get a new grid, 180 degrees, and 270 degrees. There's two possibilities for each rotation. Okay, brilliant question, well done.